Whether or not global consensus around the science of climate change can be reached, international agreements made, and greenhouse gas emissions drastically reduced, one thing's clear. Our climate is changing. Rising sea levels, more frequent flooding of coastal cities, increasingly severe weather patterns that interrupt industry, food, and water, impacts on human safety, quality of life, and national security, much less the extinction of species. Those changes are going to impact almost every aspect of our lives and futures. What if efforts to reduce atmospheric CO2 and other greenhouse gas emissions fail to achieve meaningful reductions in global heating? If we sit back and just let climate change happen, what do these changes mean? So if Plan A for planet Earth, that is reducing CO2 emissions, and efforts to develop affordable and economically competitive green technologies are not sufficient, we need a Plan B for planet Earth. A way to move the climate in directions favorable to our requirements as a nation and a world. What if we had the means and the knowledge to geoengineer our climate if necessary, to terraform Earth? We're already engineering our climate, just not in a controlled or planned manner. If we don't have a more deliberate method of engineering the planet in our back pocket, ready to go when needed, then we may be looking at massive impacts on society. This is nothing less than a planetary insurance policy that serves our nation's interests. This isn't rocket science or nuclear physics. It's a lot more complicated than that because everything is linked together. Unless we engineer a way out of such a future, we may have to live with its consequences. State actors might consider their own efforts to promote fossil fuel use or even to weaponize climate change to open up Arctic regions to shipping, agriculture, and development, if it serves their own national interests. If the climate is to be engineered, it's important that it be done for good purposes and under the most rigorous scientific controls, because if we don't understand how to do it, then someone else may instead, and we might not like the result. History is full of examples of unintended consequences arising from well-intentioned efforts to change the environment. Think of the introduction of non-native species like the rabbit in Australia or the Africanized or killer bee in Brazil, both of which upset the ecological balance in permanent ways. We have to bear this rabbit-proof fence effect in mind as we devote major resources to make sure that experiments in climate modification meet the strictest standards for safety and reproducibility, and that sustained and carefully designed monitoring efforts assure that the effects of each perturbation of the climate system are fully understood. As I said earlier, this is far more complicated than rocket science. We must begin to ask the most basic of questions. What are the emerging technologies that may most efficiently extract greenhouse gases from the atmosphere, including hard-engineered systems, biological systems, or hybrids? How would the carbon extracted by these processes best be sequestered? And where should this take place? How should such systems be powered? What if the impact of atmospheric carbon removal on the various planetary systems, terrestrial and marine, plants and animals, geological processes, water supply for agriculture, and human populations has undesirable consequences? How will an engineered climate influence society, population dynamics, the economy, and infrastructure? Can weaponization of geoengineered climate change be prevented? The range and scope of the discoveries, innovations, and societal outcomes of this effort is so vast that it covers nearly the entirety of NSF's mission and would truly represent a cross-directorate effort that could also serve as the nexus of a major interagency effort as well, in training NASA, NOAA, U.S. Geological Survey, Department of Agriculture, Defense, Department of State, and other federal agencies. We envision a coordinated effort at cabinet level with representation in the National Science and Technology Council, charged with crafting and coordinating a national action plan for geoengineering the climate system and understanding its economic and political impacts. NSF would be a lead agency working in close coordination with its partner agencies to establish benchmarks, safety protocols, funding opportunities as one of NSF's core big ideas, and integration of climate modification test results with comprehensive climate and linked social and economic system models. Let's face it, decisions of this sort rest not just on scientific consensus, but on economics and on national interest. It may not be possible to wish fossil fuels from our energy future, or to enforce CO2 emissions as quickly as required, but if a Manhattan Project for geoengineering climate provides an economically favorable path forward, the science can be translated into effective action that will actually be adopted. It's up to us to show what's possible. We're unintentionally geoengineering our climate now. The next step is to build the capability to do it carefully, to terraform Earth. Let's get to work.